In this video, we're going to tie together all of the information that we learned from adding and subtracting and scaling matrices into a lesson on how to solve matrix equations that involve adding, subtracting, and scalar multiplication. So I've got an example written already on the board, so let's take a look at how we would solve it. We're going to solve this in a very, very similar way to what we would do if we had an equation that looked like this. Okay, we would, to solve this equation here, we would divide both sides by 2, but instead of dividing by 2, I'm going to multiply by the reciprocal, and we get x equals 3. We are going to do the same thing when we solve matrix equations. So in this case, we're going to go ahead and multiply both sides of this matrix equation by a half to get rid of our 2. And I always write that scalar on the left-hand side of my matrix, never on the right-hand side. It just looks funny. It's kind of like writing x3 for a variable and its coefficient. We always just write that coefficient on the left-hand side. So when I multiply 2 times a half, I get 1. I end up with x on the left-hand side of my equation. Remember, this is on the right-hand side. This 1/2 is scalar multiplication, so I'm going to scale every element in this matrix by a half, and I'm going to get 3, -8, 0, -9. So our matrix X equals 3, -8, 0, 9. If we need to check it, we can plug this matrix back into our original equation. And you can see we could plug that right back in here, multiply every element by 2, and we should get the matrix 6, -16, 0, 18. Okay, so that was a fairly simple example. Let's go ahead and do something just slightly more complex. So in this example, I am going to take a matrix -7, -6, -1, and -12. This matrix, by the way, is a 4×1 matrix. It has 1 column and 4 rows. And we are going to solve for the matrix Y. And I want you to notice that when I write matrix variables, that variable is always in uppercase. And I believe I had mentioned that previously in one of my videos, that when we're using or choosing variables for matrices, we always choose an uppercase. So in the same way that if we had 7 equals y plus 2, we would subtract that 2 from both sides to get 5 equals y. In the same way, we are going to solve our matrix equation. We have a matrix that we need to subtract from both sides. So when I subtract this from both sides, it's going to look like -7, -6, -1, -12. Now I need to subtract that from both sides. And when I subtract it from this side, you will see that I'm going to be left with the identity matrix. Okay, I'm going to go ahead and get rid of the original problem so that I have room to work. Okay, so when I actually do this subtraction here, let's go ahead and we'll start back up here. Let's subtract these two matrices. -7 minus a -1 is really a +1. -7 plus 1 is -6. -6 minus a -1 is really a +1. -6 plus 1 is -5. -1 minus 8 is -9. And -12 minus a -11 is really a +11, so we get a -1. And that equals y. When we subtract these two matrices, -1 minus a -1, it's really a +1, so I get a 0. -1 minus a -1 again is 0. 8 minus 8 is 0, and -11 minus -11 or plus 11 is 0. And when we talked about the zero matrix, we had said it was the additive identity. When we add the zero matrix to any matrix, we just get itself. So adding the zero matrix does nothing to my variable over here. So the zero matrix, when we add it or subtract it, it's like adding or subtracting 0 from a variable. It just goes away. So our final solution is our matrix Y equals -6, -5, -9, and -1. So these were all one-step matrix equations. So now I'm going to move on and do a two-step matrix equation. So in this one, I'm going to do -3z, again I choose a capital variable, minus 10, 7, -2, 3, and that's going to equal 5, 35, -34, and 3. So the very first thing I'm going to do is I'm going to add, since I'm subtracting this matrix right here, subtracting it here, I'm going to add it to both sides. So in the last example we saw that when we add and subtract two matrices together that are the same, we get the zero matrix. So this matrix, in essence, when we add it back to the same side, we're going to get the zero matrix, so it will not change anything about our -3 times z. So when I add these two matrices, I'm going to add the elements that are in the same row and column. So 5 and 10 is 15, -34 and 7 is -27, 35 and -2 is 33, 3 and 3 is 6. So how am I going to get rid of this -3 here? Well, I am going to multiply both sides by a -1/3. So I'm going to multiply this by a -1/3. And -1/3 times a -3z is just positive z. And this number on front, that -1/3 in front of my matrix, is just scaling this matrix right here. So I'm going to scale every number in this matrix by a -1/3. So I will get a -5, a -11, a 9, and a -2. So when I solve my original equation, I end up with matrix Z equals -5, 9, -11, -2. And to test that, I could go ahead and plug it back into my original equation right in here. I could multiply it by -3, subtract this matrix here from it, and I should get this matrix over here. So let's do one more example and we will be done with matrix equations involving addition, subtraction, and scalar multiplication. So let's see. We could go ahead and do about -2x minus a -6, -7, 11, -4 equals 26, 25, -1, and -18. Alright, so since we are subtracting this matrix here, in order to get rid of it and move it to the other side, we're going to have to add it to both sides. So I'm going to cross it off here and add it over here. And when I add that, what do I get? I get -2 times matrix X equals 26 plus a -6 is 20, 25 plus a -7 is 18, -1 and 11 is 10, and -18 plus a -4 is a -22. So now all I need to do is get rid of our -2, so I'm going to multiply both sides by a -1/2. Alright, so -2 times -1/2 is a +1. So I have matrix X equals, I'm going to scale each of the elements inside by a -1/2, so I get -10, 10, negative 9, negative 5, and a positive 11. Okay, it really doesn't get much more complicated than what I've shown you here in this video. So that is all I'm going to say about matrix equations that involve adding, subtracting, and scalar multiplication.